Hello everyone, in this video we're going to be talking about how to find the midpoint and the length of a segment given coordinates. So one of the ways in which we're going to find the length of a segment is using the Pythagorean theorem. All right, this is when we have a right triangle, all right, what's called the legs A and B. This part, the long side opposite the 90-degree angle, that's called the hypotenuse. All right, and the Pythagorean theorem, a squared plus b squared is equal to c squared. This is a theorem, this is a formula that we will be using a lot. So it's definitely something you want to store in that brain. Pythagorean theorem, a squared plus b squared equals c squared, okay? We can also use what's called the distance formula. So let's say I had a coordinate here whose coordinates were x sub 1 and y sub 1. Its buddy was up here. X sub 2, y sub 2 were its coordinates. If I wanted to find the distance of this line segment, I can use the distance formula. D equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay? And these are really the same thing. The Pythagorean theorem and the distance formula are the same exact thing. All right, they just look a little bit different. So let's see why they're the same thing. So let's find the length of the same segment. One method using the Pythagorean theorem and one method using the distance formula. Okay, so if I wanted to use the Pythagorean theorem here, if I wanted to find the length of RT, RT is going to be my hypotenuse. So what I'm going to do is if I zoom in here, I'm going to drop a height and go over to form a right triangle. All right, and I'm going to draw this right triangle separately. I'm going to draw this up here. RT is the hypotenuse. That's a right angle. And now I can count just the vertical distance and the horizontal distance. So T down, that would be 1, 2, 3. That would be a height of 3. R over 1, 2, 3, 4, that would be a base of 4, okay? So if I want to say RT is going to be X, all right, to use Pythagorean theorem now, I would just use 3 squared plus 4 squared is equal to X squared, okay? So from here, I just simplify. 3 squared, that's 9. 4 squared, that's 16. That's equal to X squared. 9 plus 16 is 25 equals x squared. So from here, to get rid of that square, to undo this, I'm going to take the square root of both sides. So x is going to equal, yes, both positive and negative 5, but since I'm talking about a distance here, and distance can't be negative, all I'm going to take is the positive 5 answer. All right, I'm putting that U at the end because that's going to stand for units. So RT is 5 units long. Okay, so now what about the distance formula? Let's see that the distance formula is going to give us the same answer as the Pythagorean theorem. So R was negative 1, T was 3, 2. Okay, excuse me. So to use the distance formula here, distance is equal to the big square root of x sub 2. All right, doesn't matter which one you choose. So I'm going to say this is x sub 1, y sub 1. This is x sub 2, y sub 2. Doesn't matter as long as you're staying consistent. So x sub 2, 3 minus x sub 1, negative 1 squared plus y sub 2, 2 minus negative 1 squared. All right, minus the negative, those are going to become plus a positive. So this is going to be the square root of 3 plus 1 squared plus 2 plus 1 squared. All right, so 3 plus 1 is 4, 4 squared is 16, 2 plus 1 is 3, 3 squared is 9. So this is 16 plus 9, square root of 25, 5 units. Notice, these are the same exact thing. Okay, the Pythagorean theorem and the distance formula are the same thing. Okay, you just have to choose which method you like on these problems. I will use the Pythagorean theorem in my video notes and all that stuff because I think it's more applicable and you understand how to make your right triangle. But if you'd like to use the distance formula, that's your prerogative. Just got to make sure you know how to use them. Okay? So you'll notice the Pythagorean theorem and the distance formula right here. You see that 16 plus 9? You see that same thing over here. All right? So in the distance formula, you're just taking the square root from the beginning. Over in the Pythagorean theorem, we wait to take the square root of both sides until our final step. All right? So that's why they are the same thing. Okay? So let's do another example. Apply the distance formula. So find the distance between these 2 points. Okay? I'm going to create my right triangle. So I'm going to zoom in on this, draw down, draw over. And then I'm going to draw that separately over here just so I can keep everything organized. All right, the height, 1, 2, 3, 4. The base, 1, 2. Okay. RS, that's what I'm trying to solve for. Okay, so I've got 4 squared plus 2 squared is equal to x squared. All right, 4 squared plus 2 squared. 4 squared is 16. 2 squared is 4. So 16 plus 4 is equal to x squared. 20 is equal to x squared. So next step, we are going to square root both sides. So x is going to equal the square root of 20. All right. Now, we need to simplify our radical because we need to practice both our exact answer and our approximate answer. So let's figure out what the exact answer is. The exact answer is going to involve a radical. So how does square root of 20 break down? Well, I can do square root of 4 and square root of 5. Square root of 4 I know is a nice number. Square root of 5 is not a nice number and does not break down anymore. So the exact answer would be x equals square root of 4, which is 2, and square root of 5 has to stay underneath. So that is the exact answer. All right, the approximate answer, I'm going to use those little squigglies to say it's the approximate because it's not the exact. It's not totally equal to this, but we're just going to use our calculator to get an approximate. So if I, in my calculator, type square root of 20, I'll get 4.472. That is the approximate answer. Because we got rid of the radical and we're taking this really long decimal that the calculator gives us and we're rounding it to the thousandth place. Okay? So that's how we use Pythagorean theorem or distance formula, if that's what you want to do, in order to find the length of a segment. In the next video, we'll figure out how do we find the midpoint of a segment. Let me know if you have any questions.